Exactly. That's what we're saying, baby.
Well, my daughter has done it before for writing tests. I mean,
well, that's okay, but that's English, not microbiology.
No, history class. So, I mean, she wrote an essay and then memorized it and rewrote it.
Oh, for Mr. Corey.
Yeah, or you all the time. Just open up your computer and copy it.
Okay, here we go. Number one, I don't think anybody should have had any issues with because secant is 1 over cosine times sine, which is sine over cosine, which is tangent. We're good there, right? Yeah. Number two, I would change secant into 1 over cosine minus cosine over cosine. So we have a complex fraction because of our numerator. Okay, so we're going to multiply. Well, you could do it a couple different ways. I did it a little different with Lexi. I had her change this one into cosine over cosine, or I just multiply everything by cosine. Basically, the same thing happens. You get 1 minus cosine squared over cosine squared. Because the cosine times 1 here is cosine over cosine is 1 minus cosine squared over cosine squared, because this cosine times here. Well, 1 minus cosine squared is sine squared. So sine squared over cosine squared is tangent squared. So we just did one more step when we did ours. Okay? All right. This one. When you see a subtraction in the denominator, no subtraction in the denominator, but addition in the numerator, you got to think conjugate. So we took this one times conjugate at the top and bottom. Okay? So 1 plus sine of x over 1 minus sine squared of x. Well, 1 minus sine squared of x is cosine squared of x. And, we're done already.
Actually, when I did that problem, I was just hearing Mr. Biersbach screaming, "Do the conjugate!" That's all I could hear.
Yeah.
I was doing that one.
Yeah. Okay. Good. Okay. The next one. Cosecant is 1 over sine of x. So you get 1 over sine of x minus 1. So we have a complex fraction. So if we multiply by the denominator of the denominator that's in the denominator, we multiply everything top and bottom by sine of x. So sine of x times 1 is sine of x. Sine of x times 1 over sine of x minus 1 is sine of x over sine of x minus sine of x, or 1 minus sine of x. So it's just that. So if we distribute that, it's just that. Okay? And same thing over here. You get 1 plus sine of x with sine of x on top. So now we do not have a common denominator, so we got to make a common denominator. So when we make a common denominator, we multiply by each other. So here we have sine of x plus sine squared of x. Here we have sine of x minus sine squared of x. And then I distributed the negative sign to be negative sine of x plus sine squared of x. Yep.
Couldn't you just take that equation from the start and get the common denominator by taking it times cosecant?
Yes, absolutely. You can absolutely do it with cosecants at the start, and probably easier if you just take care of cosecants first. So it's probably easier by going, so then you get cosecant of x plus 1 over cosecant squared of x minus 1 minus cosecant of x minus 1 over cosecant squared of x minus 1 equals 2 tangent squared of x. And then subtracting these, so you get 2 over cosecant squared of x minus 1. And then this is 2 over cotangent squared of x minus 1, or cotangent squared of x. And then it's 2 tangent squared of x. Yes, it would be easier to do it that way. but some people went in the direction of sines and cosines, which, you could do it that way too.
I was just making sure.
Yep, absolutely. I think it's easier to just keep them as cosecants and do it that way. Okay? All right. So what happens here is sine plus a negative sign cancel, and then sine squared plus sine squared is 2 sine squared, and that's where we made a mistake somewhere in our multiplying, somewhere in there.
What if we do plus?
Because this is minus here, and then if you distribute the negative sign, change this to a plus, then by distributing the negative sign, because this was minus, and if we distribute the negative sign, it becomes a plus, so then we don't make any sign errors. We get 2 sine squared over cosine squared, which is 2 tangent squared. Okay, factoring. This first one, since we have a first term coefficient, we take the first term coefficient times the last term to get 6. And list all the factors. -1, -6, -2, -3. Okay? So we get -1, -6, add up to -7. So it's 2 sine of x minus 1, 2 sine of x minus 6. Divide the first one by its greatest common factor, which is 1. Divide the second one by its greatest common factor, which is 2. And so we get 2 sine of x minus 1, sine of x minus 3. Number 6. 2 sets of parentheses, split them up, cosine, cosine, minus, minus, 3 and 3. You can leave it like this if you want, or if you want to write it as, since they're the exact same, cosine of x minus 3 quantity squared, you can. Number 7 is difference of squares. 3 sine of x plus 2 cotangent of x, and 3 sine of x minus 2 cotangent of x. And we're done. That's all the further we can go. Number 8, just normal factoring. Split up the first terms, cosine, cosine, plus and minus, 2 and 7, make 14. Number 9, finding the product, we just FOIL. So 12 cosine squared of x plus 20 cosine of x minus 3 cosine of x minus 5 is 12 cosine squared of x plus 17 cosine of x minus 5. And number 10, I would write it twice and then FOIL. So if you write it twice and then FOIL, in the end, you get 36 secant squared of x minus 60 secant of x plus 25. Questions on any of those? Those most people don't have too many questions on. It's when we get to 11, 12 in these, then they start having questions again. Cosine of 75 is cosine of 45 plus 30, which if you follow the formula, cosine of 45, cosine of 30, minus sine of 45, sine of 30, is square root of 2 over 2, square root of 3 over 2, minus square root of 2 over 2, 1/2, which is square root of 6 minus square root of 2 all over 4. Good. Now, for the tangent of 15, instead of taking 45 minus 30, I suggest to take 60 minus 45. Why do I try to suggest to do 60s and 120s instead of 30s and 150s?
Because the tangent is the square root of 3 over 3, right?
Yeah, because at 30 degrees, the tangent of 30 is square root of 3 over 3. At 60 degrees, it's just plain simple square root of 3. So then you don't have an extra step of multiplying to get rid of fractions and complex fractions at all. Okay, so if you can write it so you don't have a 30 degrees in there for tangent, yeah, you try to do it that way. So the tangent of 15 degrees is tangent of 60 plus tangent of 45, or minus tangent of 45, which is tangent 60 minus tangent 45 minus 1 plus tangent 60 tangent 45. Tangent 60 is square root of 3, tangent 45 is 1. And over 1 plus the square root of 3. So you multiply by the conjugate of the denominator. So you get square root of 3 minus 1 plus square root of 3 over 1 minus 3, which is 2 square root of 3 minus 4 over negative 2, which is negative square root of 3 plus 2, or 2 minus square root of 3. So if you did it a different way and still wound up getting to 2 minus square root of 3, you're good, because there's more than one way to do some of these. Sine of 15 is the sine of 45 minus 30, which is sine of 45, cosine of 30, minus cosine of 45, sine of 30. So square root of 2 over 2, square root of 3 over 2, minus square root of 2 over 2, 1/2. So it's square root of 6 minus square root of 2 all over 4. Tangent of 75 is, a lot of you probably took 30 plus 45. And you can do it that way, but you get complex fractions. So if you take 120 minus 45, then you don't have complex fractions. Okay? So tangent of 120 minus the tangent of 45 over 1 plus tangent of 120 tangent of 45. That works as well. Because the tangent of 120 is negative square root of 3. The tangent of 45 is 1. So that you get 1 plus a negative square root of 3 here. So it's 1 minus square root of 3. So you multiply top and bottom by 1 plus square root of 3. So if you do the FOILing, you get negative square root of 3 minus 1 minus square root of 3 in the numerator, 1 minus 3 in the denominator. So it's negative 2 square root of 3 minus 4 all over negative 2. So it's square root of 3 plus 2. All right. And then with the stuff that we just got done doing, half angle formula. Okay. And I've had people do this using the addition and subtraction, and I've taken all their points away because in the directions it says solve use half angle formula. And they've done the addition and subtraction like what they did here. But I got the right answer. Well, too bad. Read the directions. It says use a half angle formula. So, goodbye points. So, cosine of 15 is the same as cosine of 30 over 2. So it's 1 plus the cosine of 30 over 2. So it's 1 plus square root of 3 over 2 over 2. So then to get rid of your complex fraction, multiply top and bottom by 2. So it's 2 plus the square root of 3 over 4, which is the square root of 2 plus, there should be a square root of 3. Square root around this 3 here. Right here, there should be a square root around that square root of 3 over 2. So Mr. Bishbach would have lost a point on that one. All right. Tangent of 75. So it's a tangent of 150 over 2. So I used the 1 minus cosine of x over sine of x formula. So 1 minus cosine of 150 over sine of 150. The cosine of 150 is negative square root of 3 over 2. So minus a negative is plus a positive. So it's 1 plus square root of 3 over 2 over 1/2. So if you multiply both top and bottom by 2, you get 2 plus square root of 3. Hey, look. Tangent of 75, 2 plus square root of 3. Tangent of 75, 2 plus square root of 3. Imagine that. The tangent of 75 is the same answer for both of them. Double angle formulas. Cosine of 240 is the same as cosine of 2 times 120. So it's cosine squared of x minus sine squared of x. So it's cosine of 120 squared minus sine of 120 squared. So it's negative 1/2 squared minus square root of 3 over 2 squared. Negative 1/2 squared is positive 1/4. Square root of 3 squared is 3. 2 squared is 4. So it's 1/4 minus 3/4, which is negative 1/2. If you look on your unit circle, hopefully the cosine of 240 is negative 1/2. And the last one, sine of 120, is sine of 2 times 60. And so it's 2 sine of 60 cosine of 60, which is 2 times square root of 3 over 2 times 1/2. Well, the 2 and the 1/2 cancel, so it's just square root of 3 over 2.